How did Zeno's paradox influence mathematics? Have you ever asked the question, if something is divided endlessly, can the end truly be reached? Zeno's paradox begins with this very question. At first glance, it seems simple, yet within it lies the deep and unfamiliar idea of infinity. This single question profoundly shaped the history of mathematics. What is infinity? It may be understood as a number without end, an unceasing process, or a state without limits. Yet Zeno used this idea of infinity to reach a strange conclusion. Motion is impossible. To travel any distance, one must first cover half, then half of the remaining distance, repeating this process endlessly. If so, should arrival at a destination be impossible? In reality, arrival does occur. This contradiction is precisely what has challenged mathematicians. In ancient Greece, Aristotle tried to resolve this problem by dividing infinity into two types. One is infinity as an ongoing process, potential infinity. The other is infinity as a completed whole, actual infinity. Yet he did not arrive at a complete answer. Like a shadow that seems within reach but cannot be grasped, infinity remained elusive. Later, Archimedes approached infinity in a completely different way. He thought of a circle as a polygon with many sides. What happens as the number of sides keeps increasing? It begins with a triangle, then a square, then a pentagon, growing step by step. Eventually, as the number of sides becomes infinitely large, the figure becomes almost identical to a circle. This idea seems to suggest infinity is not dangerous. It may be a path toward greater precision. Galileo then discovered another surprising fact. The number of all natural numbers is equal to the number of their subset, the square numbers. A part equals the whole? This completely contradicts common sense. Yet this discovery showed that, in the world of infinity, the rules we know do not always apply. And finally, Georg Cantor appears. He turned infinity from a vague idea into a thing that can be treated mathematically. Cantor proposed this idea. If two sets can be paired one-to-one, can they be considered the same size? Since the natural numbers and the even numbers can be paired this way, he concluded that they have the same size. He went further and revealed a surprising fact. Even infinities differ in size. This discovery went beyond simple curiosity and reshaped mathematics itself. In particular, in calculus, ideas such as approaching without limit and adding without end were no longer used vaguely. Come to think of it, isn't it fascinating? Zeno's paradox, which began with the strange claim that arrival is impossible, instead became a turning point that made mathematics more precise and profound. Perhaps Zeno's question is asking something simple. Have familiar assumptions ever truly been reconsidered?